All right. Shh, shh, shh. Zach, stop with the pen. All right, here we go. Now, Chantel. Number 6. The symbol delta S is used to represent change in enthalpy. True or false?
Yeah.
True. Hello, look at what you just wrote, guys. All right. Delta S is used to represent, what could I change this word to?
Entropy.
Entropy, right? So originally that statement is false. Of course, I've gone and corrected it. Number 7, Austin Jones. Chemical potential energy is stored in the chemical bonds of a substance. Very good. Jay McKnight, 8. The heat required to vaporize 1 mole of a liquid is called its molar enthalpy of vaporization. Let me just tell you this. All right. We've talked about enthalpy of vaporization, and that's all about vaporizing or boiling something, right, Michael Albert? Okay. Now, we haven't talked about it for a mole, but this is a true statement. Number 8 is true. Number 9, rusting. All right, spontaneous. Spontaneous means that it happens without any intervention. All right, what this means is it happens all by itself. Does rusting happen all by itself? Yes. So this is true. It is a spontaneous. Oh, thank you, girls. Good job, Kimberly, Josh. And I'm going to give you a ticket for that. You caught my. Shh. Too much talking. Too much talking. Josh. Shh. They caught my oversight here. Rusting is not a spontaneous process. It is a spontaneous process, so the statement, the way it's written, is false. Now, number 10, here's your definition. David, is this number 10 true or false? Spontaneous process is a physical or chemical change that requires with no outside intervention. True. Taylor, number 11, this equation shows an endothermic reaction. Look at the sign. Is that positive or negative? This sign right here. That's a negative. Negative means exothermic. Write this down. Write this down. Positive means endothermic. Negative is exothermic, positive is endothermic. So Taylor, what are we going to say about this? Is this true or false? False. Very good. Number 12. The SI unit of heat and energy is the, well, guess what the answer to this is? C, a joule. All right? Shh. Number 13. This information is on your laminated sheets. Jay, this information is on your laminated sheet. 1 calorie is equal to 13, 4.184 joules, and you'll find that on that list of equivalents, okay? Now, number 14. It shouldn't be hard, and you need to, some of this stuff I'm teaching you for the first time, but it's not teaching you for the first time, but pointing out to you how you find the answer using your laminated sheet. But keep in mind, on test day, things tend to be a little bit more challenging, especially if you're on your own, okay? Shh. Number 14. Convert this energy to joules, all right? You know what? There is 440 kilocalories. Watch this. This is dimensional analysis. It's been a while since we did this. What did we just say that 1 calorie is equal to in terms of joules? All right, so what do I do with those numbers, Jay?
You multiply across and
Multiply across. There's nothing to divide by on the bottom, so I multiply across, and I should get A right here, okay? What if your answer is not exactly the same as their answer? You pick whatever's closest, don't you, David? All right. In my calculator, I get this big old number. But remember, when you move the decimal over 1, 2, 3, 4, 5, 6, all right, make that a positive exponent because I moved my decimal to the left. Shh, guys, I need you to focus. Stay focused. Stay focused. Shh. 15. This question has tripped people up for years. This question has tripped people up for years. Number 15. What do you think the right answer is? Look at it and evaluate it.
it's C.
All right.
It's C.
If I just look at this, I'm going to say as pressure increases, temperature increases. But that's not one of the answer choices, I don't believe. All right? Now, as temperature increases, pressure decreases. I know that's wrong, correct? B, as temperature increases, pressure remains the same. That can't be right. Shh. C, as pressure decreases, temperature decreases. Could I change both of these and then still have it be a true statement? Yes. Are they inversely related? No, they're directly related because one goes up, the other goes up. So that's not the right answer choice. So C is correct. Number 16, which is incorrect about the student's graph? All right, units and title. They give us temperature. Is that a unit? No, we need a unit like degrees Celsius. We need a unit for pressure, something like atmosphere. All right, so A is the correct answer here. Number 17. 17 is back from chapter 13. In this equation, 1 volume of hydrogen yields how many volumes of hydrogen chloride? The volume to volume ratio is the same as a mole to mole ratio. So how much, Chantel, hydrogen chloride, how many moles of hydrogen chloride can I make here? 2. Very good. All right. That one isn't hard. You just need to make sure that you understand that the mole to mole ratio is the same as the volume to volume ratio. Number 18. This is a PVT problem. I'm not going to work this whole thing out. What's the one thing, that's the equation you're going to need to use. What do you have to do with your temperatures? Zach, what's the trick that we have to do with our temperatures when we do this problem? Convert to Kelvin, right? Right? Okay. So make sure you convert your temperature in this problem. And then number 18, guys, you'll see that you've been given an answer key. Do you see that you have an answer key on the back of your paper here? You've got B for the correct answer. Number 19, Dallas, I think you know this one. The Greek letter delta stands for what? D, change in. Very good. Okay? All right, thank you. All right, good. Oh, can you alphabetize these? The girls rated them first block. They're just not alphabetized. So I can get it quick, you know what I'm saying? Number 20, heat of vaporization is being added during which segment? Now, y'all can see this better than I can. Let's go with Devin. Where is heat of vaporization being added? During which segment here? D. Very good. Liquid and gas. It's hard to see, but everybody should know that that's right here, the section between liquid and gas. Good. Let's turn it over. Let's go to 21. Why is the temperature not changing during the 2 state changes shown? All right. Read through your answer choices. Read through your answer choices and pick the best one. I'm going to give you 30 seconds.